Hello, welcome back to the channel. So let's do a couple more questions on substitution and then we'll go over the next concept. So this is also a question of substitution. You basically have to evaluate the indefinite integral of tan x log of cos of x, and you'll realize that the best way in order to solve this the indefinite integral is basically by using substitution, because in this question you'll realize a pattern which will force you to use substitution as the best way of solving this indefinite integral. So first of all, if you don't know about the process of substitution and using substitution in order to calculate definite or indefinite integrals, I would highly suggest you to first watch my previous videos in order to get the full context of this. And a quick overview about substitution is whenever you want to identify if you have to use substitution in your definite or indefinite integrals, expressions, evaluations, you basically identify a function for which you are also provided the derivative of that function in the same integral expression, which you'll clearly notice in this question as well. So in this question, what do you think would be a good guess for the function u for which we already have a derivative of that function present, right? So now if we go for a first guess, let's take a first guess to be cos x. We know the derivative of cos x is minus sin x, and tan x is also sin x over cos x. So we know we have a sin x term and we have a cos x term, but you'll clearly realize in this question that when you'll take cos x as your original function, as your guess for a function u, you'll soon realize that you'll be taking an indefinite integral of 1 by u log u, which will not help you a lot, right? So that is why it would not be much useful to take cos of x as our u function. But what if we take log of cos x as a function? So let's try with that. Let's suppose our u is log of cos x. In this case, if we take the derivative of u with respect to x, we know that the derivative of log is 1 over that part which is inside the bracket, so it would be 1 over cos x, and because of the chain rule we'll have to take the derivative of cos x as well, right? And you'll see in this case that du by dx is 1 over cos x, and we know the derivative of cos x, which is minus sin x. So if you simplify this down, it is minus sin x over cos x, which can also be written as minus tan x, right? So you realize this thing, that if we take the derivative of our u function, which we guessed as log of cos x, we get minus tan x, and we can also see a tan x expression over here. So that gives me an idea that it's better to take u equals log cos of x as my correct guess rather than taking cos x or tan x, which will not help me a lot in order to solve this indefinite integral, right? So now let's go with this u function. So we know that our du by dx in this case is minus tan x. If I shift the dx to the other side, your du would be minus tan x dx, and we also know our u was log of cos of x. So now let's write our original integral for which we were calculating an indefinite integral for, and that was tan x log of cos x dx, right? Which you can also confirm in this question, tan x log of cos x. And now let's rearrange this equation so that it's easier to visualize what we are doing in substitution. So I can write this as log of cos of x times tan x dx. And now we can just substitute log of cos x as u, and we can substitute tan x dx as minus du, because du is minus tan x dx. So if we want to substitute tan x dx, it would be minus would go over the other side, so it would be minus du, right? So now let's do all the substitutions. So it would be u times minus du, right? And if we simplify it further down, it would be minus u du. Minus can be taken out, right? So it would be minus of integral u du in this case. And you already know the integration of u, which is u square by 2 with a minus sign because negative is taken out. So it will remain in the final expression, final answer, and with a constant of integration added to it, because we are calculating an indefinite integral in this case. But the question is not solved yet. You have represented your answer in terms of u, but we didn't have any u in our original question, right? We had everything related to x, so that is why we'll have to shift everything from u back to the x expression. And since in our original expression our u was log of cos of x, so we'll have to convert every occurrence of u with log of cos of x. So your final answer would be minus of log of cos of x square upon 2 plus the constant of integration. So now this would be your final answer. This is not your final answer because you still have u and you didn't have any u in your original question, but this would be your final answer because whenever you're calculating an indefinite integral, which is in terms of dx, your answer is expected to be in terms of x as well, rather than having your answer in your personal function notation. So that was an important point, that whenever you're changing some of your functions in your integral to different functions, you'll have to convert those new functions back into the original expressions in order to get to the final answer. And again, don't miss out on the constant of integration because it's an indefinite integral, so you'll always have a constant of integration in this case. So that's it for this video. I hope you found this video interesting. We will do a couple more questions on substitution and then we'll move over to the next topic. Feel free to comment down on this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.